hi all. If it's okay with Mike and Lisa and Xiaoping, I think Dylan, our other co-chair, will hopefully join. But I think, should we get things moving? I see Don's joined us as well. Xiaoping, are you okay to start? And if so, maybe we can just give a quick intro to the China Working Group. And maybe Sammy, you can help moderate that.
No problem. I think we'll wait for 1 minute. So I think it's 9:29 now.
Sounds good.
It's 9. Yep. Xiaoping 可以了吗？
可以了，应该目前情况对大家应该得到了。
Okay. Okay, maybe I'll just kickstart the event. Just in the interest of time, I would like to first of all welcome everyone joining today's meeting. I would like to highlight that all FIX meetings are conducted under the standardization IP policy of FIX. If you need more information, please visit the FIX protocol or FIX trading community website for more details. Today we are going to have a presentation about Google protocol buffers. We have Mike Gattney joining us, and also Donald Madison and Greg and Lisa joining us from the technical committee. But I think before that, Xiaoping, do you have anything to say?
是这样，就是首先呢，非常感谢那个 FIX Trading 委员会给中国区的同行带来这次的技术培训啊，因为今年我们6月份的时候也开展了一次的那个 SB1 的那个简单而精致编码的一个讲座。那么 SB1 和这次的这个 GPB 呢，都是那个 FIX 高性能工作组的一个方向，目的是提高这个 FIX 的这个接入的性能和便利性。那么在消息传输过程中的一个编码和绘画的一个挑战。那我的同事那个朱立先生也是这个 HPWG 的一个成员，他今天也过来了。那么这次的这个 GPB 的讲座呢，让我们更加了解这个 FIX 编码技术的一个方向，有利于我们在这个证券期货行业的一个推广应用。就是待会在这个讲座过程中呢，如果大家有问题，可以随时提问。那么直接用中文也可以，用英文也可以。那么也可以打字啊，就是在那个聊天里打字也可以。那么同时也希望大家再思考一下，就是下一次的会议，我们还有什么需求，有什么想法，也可以在这里提出来。就这2个要求。那么感谢麦克和 Greg， 还有唐纳德先生和 Lisa。那么我就这些，Sammy。
谢谢。首先，如果是你有问题的话，你可以用那个举手功能，我可以看到那个举手功能。等一下 Q&A 的环节的时候，我可以给你打开你的麦克风。或者是说Xiaoping刚才说的是可以用那个 Q&A 的那个功能，也可以用文字也行，我们也可以回答一些。然后等一下如果是有什么问题随便的是打进去。然后现在我先邀请那个 Mike 做那个presentation。Mike, I think we're delighted to have you today. Maybe I will hand over to you to make the presentation on GPP.
Sorry, Mike, before you begin, just to let you know, Sammy and Mike, Greg also just joined.
Hello.
Okay. Sure, and I'm happy to get us started, and Sammy, if you can just let me know, areas of interest. So I'll start off with an overview, and then we can get into Q&A, and we can get into particular topics that might be of interest.
No problem. Yes, please go ahead.
Okay. Hi, ni hao, si sheng hao. My name is Mike. I'm a member of the fixed trading community, and I chaired and wrote the specification for the JSON encoding of fixed protocol. And we've recently begun to use the protobuf encoding extensively at a particular client. And so we have some good examples of that being used in industry and using fixed orchestra. So I'll start off. I've got some slides here, which I believe you can see shared on my screen, and I'll just get us started, and we can use this as a point to begin discussion. First of all, with characteristics of the fixed protocol buffer encoding. Of course, protocol buffers is it's a technology that came out of Google. It's language neutral, platform neutral, and it's fairly well known and widely used. It's over 20 years old at this point, so it's not a bold choice technology wise, and it has a lot of support in different programming languages and platforms, and continues to be developed and supported by Google. Some of the advantages that make this useful for fix, it's actually it overlays fairly well onto fixed protocol and for encoding fixed messages. The specification is open, as is the fixed specification, and so it's usable by anyone on any platform or language. And so even if Google were to not support it further, it's openly available to everyone. It's usable from C++, Java, Python. At this point, almost any language you'd care to use. There's no need to write custom code to decode or encode the binary format like there might be for some exchanges that use custom binary encodings. It's a flexible encoding. It uses not necessarily a tag equals value format, but it does use named fields, and optional fields are supported. This maps well onto fixed protocol because, of course, in fix we have fields which are optional or conditionally required, and this is an advantage over a format like JSON or other formats that are more dynamic, because it offers us a little bit more structure and a type system, so that we can be sure of what types are, and we can be sure about what happens when we change the specification or the version of a message, and we can understand what that means throughout the system in a way that maybe we couldn't if we removed a field from a JSON message. It supports versioning, which means that messages are backwards compatible across older versions, so we can add new fields which are maybe optional to a message, and it won't break existing software. That software will continue to work, and it may not understand the new fields, but it will also it will simply ignore them in a way that sometimes fixed implementations would not. They might reject messages with fields that they did not know, or message types they did not know. Performance. These are binary messages. They're compact. Version 3 of the protocol is extremely efficient on the wire, but there are even more efficient versions, such as CAP and Proto, and I'll get to that in a later slide. They're CPU efficient. They're easy to decode in the CPU, so we can send a large volume of messages efficiently, which also maximizes network bandwidth. And makes it quick to serialize and deserialize the messages. They're easy to use. They're easy to learn. You don't need to teach someone this format. It's well documented. Google has done the heavy lifting here. They've done the hard work to document it for the protocol itself, but also for individual languages from which you might use it. So there's no need to create your own custom documentation for a custom wire protocol that you might develop. It's already out there and supported by people in the community, so you also don't have to support everyone trying to learn it. The messages are structured just like fixed messages are, so there's repeating fields, nested groups within the messages. We actually have an advantage in the case of protobufs over fixed tag equals value because we don't need to introduce additional constructs like the parties fields and the nested parties fields to accommodate similar repeating groups within the same message. They also have what we might call a template structure, like we had in fix fast, or that we see in things like simple binary encoding for fix. The messages have a structure which is defined in a protofile, which can be shared with others if you want, and can be generated from something like Fix Orchestra. This gives the files, or this gives the messages a strong type versus something like JSON, which without a schema can be very flexible, but also could be anything, which can create difficulty when reasoning about a system and what happens when you add or remove a field from it. So we have a nice we might call an IDL or interface description language in the form of protofiles, which defines these messages and can even help us define services that send these messages. And then in terms of adoption, protobufs have a large user community. It's been active, like I said, for over 20 years. So at this point, there's plenty of support in the community for this message format in general, and therefore, when applied to Fix, it makes it a little bit easier to adopt something that already has such a wide user base. And I'll pause there. So that was a lot. I'll pause there in case there's any questions or translation needed.
Uh, 小平有什么特别的要提问，或者是说可以继续？
或者我们就继续吧，还是
OK， 没问题。Greg, you have anything to say?
No, that was a pretty good. Let me make sure you're hearing me. Yeah, you should be hearing me.
Yep.
No, the one thing I'd mention is the versioning. The compatibility works very well. You can add new fields and they'll just be ignored. Although there's a caveat there. Be careful if you ever delete a field, and then there might be an issue there. But in general, it's the versioning is very well.
Okay, if no further question, I think Mike, yeah, please continue.
Okay, so in terms of protocol buffers themselves, Google provides official versions for the most commonly used languages like Java, C++, and Python. And of course, if you're using this along with the fixed protocol encoding, this works seamlessly with those tools. An additional tool which can be interesting is gRPC, which provides a remote procedure call framework on top of protobufs. So you can actually add service definitions on top of your protos and create RPCs that build off of those and gives you opportunities to generate additional code for your clients and servers so that you can use the protos in a structured way with those services. And it tends to be extremely useful. Those gRPC services, just like protobufs themselves, are supported by Google. They support by default HTTP2 as a transport, but you can also add on the gRPC web proxy to that, which will give you a REST implementation right on top of that. So for free, pretty much, you can get protobuf messaging plus gRPC messaging plus REST messaging sort of for free out of the box, just using those tools. And we've used those tools extensively at our firm and for our clients to build these types of services that are based around Fix. There's also utilities for printing and displaying the messages in different ways. It wasn't always the case, but it is the case today that protobufs can be converted to and from JSON format. So if you're using JSON formats elsewhere in your system, or if you need a human readable way to log or debug messages or to pass them to web-based applications, that's now natively supported within the protobuf tooling to convert to JSON format. There's no encoding or decoding that needs to be written by hand, as it is the case with other exchange formats where you may have to implement their specification, their binary specification on the wire. If you use something like protobufs, there's no need to write your own encoder and decoder. Those are already available and open source, and they work in pretty much really any language now. There's really no programming language not supported by these things that you would be likely to use. There are other utilities that can convert these formats to XML, JSON, HTML, and these are all freely available and don't need to be written. So if any of those things are needed, they're already there. And there's a list of those that Google provides on their wiki. They have any number of third-party add-ons for these things. There's lots of ways to plug this format into existing systems. And I'll pause there again just in case there's questions, but I can move on when you guys are ready.
有什么问题吗？
大家有什么问题可以直接提啊，再打开这个静音。
可以举手。如果没有的话，可以继续吧。Mike, you can continue.
Okay. Okay, so now getting into more of the specifics of using protobufs specifically for fix as opposed to so far we've talked about protobufs themselves, but one of the first things that becomes important when sending protobufs over fix is that we don't have, if we're just using protobufs, we don't automatically have a session protocol or even we really just have a stream of TCP messages. We need to decode them somehow and frame them as messages. In a normal fix engine, we normally would have this already in a fix engine that would parse messages and hand us a fixed message from whether it's tag equals value fix or something else. We would already have something that could take a stream of bytes and convert it into actual messages. So if we're going to use protobufs, we need to do something additional to get that. One option is to use the simple open framing header standard that Fix protocol provides. This is one way to add some framing onto the message to delimit when one message begins and ends and the next one starts after that. So one way to do that is to use the Fix protocol simple open framing header, which defines a very specific way within the GPB encoding to do this. There's some specific headers that are recommended to be used there, and that's one option. Another option is to use an alternative mechanism, and that's to send these messages formatted as protobufs over something else, which could be a message broker, message bus, it could be JMS, it could be Kafka, it could be RabbitMQ, IBM-MQ. There's any number of transports that could be used to send these messages that would provide that framing for you. And in my own experience, this is what we've done the most. We've used all different sorts of message buses, whether it's Kafka, RabbitMQ, ActiveMQ, IBM-MQ, to send these types of messages around, and that's what we've mostly done. But Fix protocol also provides a standard for this type of framing in the absence of those other types of transports. But if you are using a higher level transport, like a message bus, there are still some recommendations that you can use to let the consumer of the message know what's contained there. And I've listed those here as message length, encoding type, proto identifier, proto version, and message type. And this really is a way to tell the receiver of the message what the encoding is, how to find the proto file that describes how to decode the message, what the version of it is, and then what the fixed message type is. And other things that you might want to include, or ways you might want to include them, would be to put them into, if you're using HTTP, you could put them into an HTTP header. If you're using JMS, you could put them into a JMS property on the message. So there's different ways to to convey this information, and others will make their own internal custom versions, which is something that, in my experience, we have done ourselves because we may also want to include authorization or authentication information in each message and make that part of the header that we send along with these messages. So I'll pause again right there.
Hey, Mike,
Sammy, any questions?
Mike, it's
Oh,
Greg.
sorry. Yeah. Hi, Greg.
Any experience with REST APIs?
Yes. So we use we use the we use a combination of these tools in concert. So we use the gRPC web framework, which goes on top of gRPC. So we encode things in protobufs, pass them around internally that way. But when we expose them to the outside world, we expose them with a gRPC API for those that are able to consume that. And we also use gRPC web to convert that to REST. And when we do that, we do a combination of either exposing the protos directly over REST or converting them to JSON encoding.
Yep, makes sense.
So and all of these tools are available as part of the fixed trading community stack of tools. You know, there's all these standards all are there, and it's a combination of open source tools that are available in general, and then ones that are provided by fixed trading community, and we use those all in concert to sort of build systems that put these components together. A lot of the time, what we do is we use the protocol buffers internally over message buses like Kafka. That's usually in the cloud anymore, but still sometimes on real hardware for certain situations, and we use that completely internally. And then when we expose things to the outside world, we create gateways, services that convert that either to fixed protocol, you know, traditional tag equals value, or using gRPC APIs, or using gRPC with gRPC web to provide REST, and to give people the option to use those protocols that are fairly standard and easy for people to use in the cloud, which a lot of things more and more are running in. So we're able to combine these technologies together, but without having to create completely new standards or bespoke standards to do it, because we now have the various fixed trading community standards in concert with open source tools like protocol buffers, quick fix, and other things.
Okay, thank you. Mike, yeah, please continue.
Okay.
Oh, yeah,
Okay, so tooling. One of the main.
Xiaoping, you have a question?
对，我问一下，就是刚才那个他说 TCP UDP 的话，会不会有什么问题？如果基于 UDP，
可以再说一遍吗 ？Sorry，
就是如果是基于 UDP 传输的话，它会不会
？I think the question is if you are using UDP, what was the next one? I cannot catch the second question. 用那个 UDP 的话是要用 API 吗？是不是这个问题？
对，是的。就是会在 UDP 上传输，它是不是有什么特别要做的，还是说没有什么问题？
I think the question is if you use UDP, do you still need something special on the API?
So I have not used protobufs with UDP. I don't know if Greg or Don could comment on if simple open framing header could accommodate in this case, where we could encode protobufs over UDP and potentially spanning multiple datagrams, but using simple open framing header to accommodate in that case. I'm not familiar enough with that to know, but you would need a mechanism like that to frame the message, because you could very easily span a datagram, I think, with a large protobuf message, if it had enough repeating groups in it. So I don't know if Don or Greg, if you have any familiarity with that.
Yeah, I've no experience doing that specifically, but you're right. You still want to have a framing header just in case you're spanning multiple frames and packets and whatnot.
I was just about to interject before that if you had a restriction where you did not have to span multiple packets, then in essence, the rule would be that the packet size is your message size, and that would in essence be the frame. But if the messages are too large, obviously you can't do that.
Yeah, so very much if you could fit a protobuf into one UDP datagram, you'd be fine. Otherwise, you'd have to do what other protocols have done, like itch uses mold UDP 60, whatever they call it, mold UDP 64, to give that length so that you would know that there's a continuation across datagrams. But if you knew that based on your message format that you could fit them in one datagram, you'd be fine. But you'd need to know that to me that you wouldn't span datagrams. Otherwise, you need your header to let consumers know that that the bytes continue in the next datagram.
Okay, please continue.
Okay, so specifically some tools that we can use when converting from fix to protobufs. There is a tool provided by Fixed Trading Community. Greg on the call is one of the originators of this tool. It's called Fix Orchestra Protobuf, and it will convert Fix Orchestra file into a variety of protobuf compatible versions. So Proto V2, Proto V3, and Captain Proto, which I mentioned earlier. The Captain Proto is a variant of protobufs written by the original author of protobufs that aims for performance, aims to be more performant than the original protobuf encoding. But this tool can produce all three variants, and it works with a fixed orchestra file. So if you have your messages described in fixed orchestra, you can use this utility to produce protofiles, and it's one of several tools that Fixed Trading Community has that will take a fixed orchestra file and produce other things. So you can, in addition to going from orchestra to protobuf, you can go from orchestra to a quick fixed data dictionary or any number of other things. One way to try it out, if you don't already have an orchestra file, is you can use the standard orchestra fixed latest file, and you can run it with this utility and produce a directory of protofiles that you can use as you would with any other protobuf application. And I've just given sort of an abbreviated example here. These files tend to be quite large, and they're human readable, but of course they're more meant to be read by a computer. But this is sort of an example of what would happen if you produced an execution report, or what an execution report would look like as produced in proto format. And if you're familiar with that message, this won't look totally unfamiliar to you if you know protobufs at all. This utility will convert the fixed types based on the orchestra definition. It will produce the fixed data types into the protobuf format. So for example, a price field in fix will become a decimal 64 field in protobuf. A string field in fix will become a string field in the proto, and so on. Any kind of repeating group will be a repeated field, and embed the protobuf message type. You can see here in this example that we have the exec inst enum as a repeated field, and that's actually a way that we can take protobufs the way that they allow embedding of a message within a message to recreate the way that repeating groups work within a fixed message. And so all of those data types are mapped across, and then also attributes come across as well, which give us in protobuf we can take the orchestra description of the field, for example, what version of fix it was added in, or what the fixed data type is, and that comes across into the proto file as well. So if we wanted to use that metadata for conversion or other things, it's available in the proto file as well. But it's a fairly straightforward conversion from what the fixed message would normally look like in tag equals value fix or traditional fix encoding that we would think of, and it comes across into the protobuf encoding. And so I've given an abbreviated example here. Like I said, these get very long, and but they are broken up into multiple files. If it was all in one file, it would be quite large, just like an orchestra file could be quite large. And so a really easy way to try this out is to just take the fix latest orchestra file and run it through the utility and see what it produces. And then from there, it's like using any other protobuf files. It's exactly what you'd expect, and with some nice packaging and other markup. Any questions there before I move on?
I have a question. The attributes that are added, like field added and tag, those are metadata. Those are not sent on the wire, are they?
No, those are used by the the protobuf tooling, that when you you generate the code and you're using their libraries, you can actually query those to get that information, but that information does not go over the wire.
Yeah, and one of the bits of tooling provided, the way that this used to work is that you could write extensions to the Proto-C compiler to do things based on those attributes. The way it works now, it's actually fairly clever. The modern version of it is when you want to write extensions to the Proto-C compiler, the Proto-C compiler will pass your main program a proto file on standard input, and it contains what you would have had access to previously by writing a C++ extension to it. So it sends you a proto on standard in, and you send it a proto on standard out, and you're able to see all this data. So if you want to do custom code generation, you can do that. So ways that we've used that in the past at Connemara is we might use our protos to do things like create, SQL statements, things like that, other things you might want to do with the format, using it as sort of the golden source. Now that we have Orchestra, you could do the same things with Orchestra, but we used to use existing formats like that and write our own custom extensions to Proto-C to do that. And so if you did want to extend the code that's generated by the Proto-C compiler, you have an opportunity to do that by writing a plugin and getting access to the metadata that's provided there. So if you wanted to mark up your code with annotations or other things to let you know things like what fixed tag it was, or what fixed data type it was, so that you can convert it back into something else later, you'd have access to that. But over the wire, no, it's strictly for when you're compiling the proto files and doing code generation.
Okay, yep, please go ahead.
Okay. All right, usage in the industry. This one, I don't know if anybody else on the call has additional information that I don't know, but I think this is difficult to gauge. But I know that we did have a survey fairly recently, within the past year, about Fix Orchestra adoption. This one might be interesting to find out what adoption is. There are members of this panel who are currently working on a project in the industry that's going to process pretty much every exchange traded derivative trade that happens. A very large percentage of them, and we're using this combination of tooling. So we're using Fix Orchestra, we're using the protobuf encoding, we're using the Fix Orchestra quick fix utility to get quick fix data dictionaries from the Fix Orchestra file. So this stuff is being used. It's just, I think maybe with a lot of things, related to fixed protocol, it can be hard to tell sometimes without asking maybe the fixed trading community to weigh in on it, because you know, a lot of this stuff happens behind closed doors. But I can tell you, as a systems integrator, that we do use these tools, and they are out there. But I couldn't possibly say what the adoption is. I don't know if anybody else has info there.
Yeah, Mike, I think that's the big challenge about finding
Could we do
out
a survey? Yeah, could we do like what we do?
I
with
mean, we can
orchestra?
do surveys, but a lot of people just don't want to talk. That's
Yeah,
what I've
yeah.
always run into. Even just trying to find out adoption of fixed application messages is hard enough.
Right. Yeah, I mean, we know.
I mean,
like, how many
I
people
do
download
know.
Quick Fix. We know
Yeah.
that. And then how many people ask us for support contracts for it? You know, it's yeah. The other things, that's how it's hard to
Yeah,
know.
it's hard to know.
But it is in use, and I know that we're certainly using it and have done.
那个我有个问题啊，就是说，咱们这个GPB 有没有一个使用许可证的问题，就是 license 使用许可的问题？
小编你可以大声一点吗？其实听不清楚。
就是这个有没有一个许可证的问题 ，GPB 的使用有没有 license 啊，或者说一些许可的一些障碍或者一些要求啊，就是它这个完全开放呢，还是说使用需要得到某些的一个认可啊或者认证啊这方面。
Okay, I think the question is whether everything you mentioned here is open source, or anything you need to have any licenses, or have to pay or be certain part of a membership or anything.
I think so far everything is open source, although maybe Don could correct me if any of the tools I've mentioned are not available to anyone or only members of fixed trading community. Certainly the fixed orchestra protobuf and fixed orchestra quick fix tools and all the protobuf stuff that I've mentioned that's specifically protobuf not fix related is certainly open source. I think all the fix related things are open source, but they might be, I know some things are still guarded on the fixed trading community GitHub.
All of the software from Fix that is public is under Apache 2.0 license, which is a pretty liberal license. And obviously Google Protocol Buffers itself is open source. I'm not sure what the license is.
But Don, I think the question too is any of the tooling stack that Mike mentioned in his presentation, are any of them private members only?
I'm checking right now in the incognito tab.
I don't believe so.
I'm checking right now in an incognito tab, and they are not. They're public, and they are Apache license version 2, which makes them a very liberal open source license. And I can do a quick check here on protobuf itself.
Sammy, I also see a hand raised in the attendees.
Okay.
Yeah.
Let me allow him to speak. I have Kelvin asking a question. Yep, I allow you to talk. Kelvin, you can switch on your mic.
OK， 可以听到，可以听到吗？
可以听到。
就是有一个问题啊，就是刚才那个前面一页那个 PPT 里面，我看就是从那个 orchestra 里面生成出的那个点 portal 文件，它有一些那个编号嘛，每个字段它的右边都有一个编号，然后那个编号它是有没有一些特殊的安排？因为我们知道就是portal buffer 它有一个特性，就是说你不同的这个 message， 然后如果你里面有一些编号一样，并且字段的类型都一样的话，你事实上是可以用一些更简短的一些 message。但它的编号和字段类型都一样，你可以去解一个更大的一个 message 里面的那个提取出那些就是必要的一些字段出来。 有这个特性。然后这样的话，就是说你在就是从这个 Orchestra 里面生成出的这个点 portal 文件的时候，有没有去考虑一些就是把一些就是常用的字段让他们的编号在各个消息中维持一致。
OK， 我尝试做 translation。Mike, I think go back to the previous PowerPoint page.
Sure.
It's about the I think he's referring to there was a number in the protocol in the POBO file. Does that actually represent something? And then what he also mentioned is there a way that you can we can simplify the process by numbering a particular kind of process that are often used, so we can easy in terms of the coding. I think I try to get that translated.
Okay, so I think maybe referring to, for example, it says like, I'll take one of the first fields, string account equals 1. So this is simply that's the way that protobuf declares a field, and the reason you do this is it's because of backward compatibility. So each field is numbered that way that you add, and if you add fields, the best practice is to add them as the highest numbered field, because this is literally the serialization order that protobuf will send the fields in. And so as long as any new field appears at the bottom, this is how backward compatibility works. If let's say you have fields, account equals 1, average price equals 2, sealer ID equals 3, and that's the only fields you have, and then somebody adds cumulative quantity equals 4, an older piece of software would still be able to decode the first 3 because it understands which order that they occur. So those numbers are literally the order in which they occur in the binary serialization, and they're important for backward compatibility. Best practice is to add any new field at the end. The protocol buffer encoding for fixed protocol takes this into account and allows those new fields to be added at the end of the message. The other numbers that we see in any declaration that are inside of the square brackets, like for example, in account, it says string account equals 1, but then inside the square brackets, we have tag equals 1. That's the fixed tag that ties back to the account field, which in this case happens to be the same. It's tag 1. We can see in the next one, average price equals 2. We see tag equals 6, and that tag equals 6 is the fixed tag for average price. So that's what those are the numbers that are occurring in these fields. And then Sammy, if you could clarify on the second question about the tooling about generating messages.
Kelvin， 是第二个问题是说，是不是你再说一遍你的问题，是不是说
就是就是比如说啊，有2个消息，就是说就举个例子，就像这个PPT 里面的这一页，它有一个 execution report。如果我还有一个就是new order single 的话，如果两个 message 里面它都有一个字段叫 account， 那么在这个在生成这个点 portal 文件的时候啊，就是那个工具它会不会就是做一些特殊的这个类似于 arrangement 一样，就是把这个同样的 account 他们的这个就是边上的这个 ID 啊，这个 field number 都设置成为1。这样的话，其实我可以做一个更小的一个 message， 比如说我做一个叫做 extract account， 做一个很小的很简短的一个 message， 只有一个包含 option 的字段，就叫做比如说 account 等于1。这样的话，我就可以把这个很简短的 message 去用来解这2个大 message。这样的话，我就可以从里面提取出它的 account 出来。就如果他们的这个 account 在每一个 message 里面，它的那个field number 都是一样的话，就是它工具
是说
做安排。
你意思就是这2个 message 要把它压缩成一个包，是吧？那这样呢，这2个，比如说 new order single 和 exclusion report 这2个，那么它就可以放在一起。
就是说，我们可以在不关心这个 message 到底是什么类型的情况下，只提取它的关键字段出来。就如果它的 message 的里面某一个字段，某一个就是同样类型的，比如说 account， 它的 number 都赋值为1的话。
it sounds a little bit more complicated to me. But generally, I think the question is, if say there is a field called account equals to 1, for example, can you sort of simplify the messaging in a way that as long as we have this kind of message feature, the decoder or can sort of add the feature, so make the length of the message much even smaller, so simplifying the decoding process.
Yes, so we can have what I've shown here is generated off of the fixed latest orchestra file, but we can customize just as you can customize any fixed message using other encodings like tag equals value, the traditional fixed encoding. Just as we can customize those, we can do the same here. So we can include or not include any field, just like we can with any other encoding of fix. So we can do the same thing here. And an orchestra is not required to produce this encoding, but it's probably the one of the simplest ways to produce it. But you don't have to. You could also write your own protofiles that follow the standard. But you have the ability to remove any field, customize any field, just as you do with any other encoding of fix.
And you do that before you pass it through the utility, right?
If you were going to use the fixed orchestra protobuf utility, then yes, you'd customize your orchestra file to the way that you want, so that it represents the message with the custom fields that you want, or the limited number of fields that you want, and then run it through the utility to produce the proto files. Or you always have the option to write the proto files by hand. But a great way to do it would be to use the orchestra file and just take out the fields you don't want or add the fields you need, and let it generate this for you. And then that way you can generate other things from that orchestra file as well, including a quick fix data dictionary for traditional tag equals value encoding and other things.
Okay, Kevin, 他解答你的问题吗？
解答了一部分。
等一下可以再提问。然后苏威，你有问题，我给你打开你的麦克风。苏威，你有问题吗？他可能没法打开的麦克风。然后Mike, please continue first, and then we will have more time for Q&A later.
Okay. Okay, so we talked about a little bit about usage in the industry. It's a bit difficult to gauge, but people on this call are engaged on projects in the industry that do use these utilities. So although it's hard to say, exactly how many people use it or not, certainly the people that know an awful lot about these things use them on their own projects and recommend them to others. If that's any kind of endorsement whatsoever, maybe it is. And then the evolution of the standard, as with all fixed standards, this is a fixed technical standard. It's at version 1.0. This is an official fixed encoding supported by the fixed trading community. It's in the 1.0 stage, which means it's an official technical standard. It's no longer a draft. It's officially out there, as are the other encoding standards. And as always, the fixed trading community's work is to continue to develop and promote these standards. So this is one of them, and we'll continue to support it and promote it. Various of these utilities and standards are supported not only by fixed trading community, but the member firms that make up that community and the people that are part of those firms in that community, including me and the other people on this call, support these things and back them and continue to develop them. And so this standard has the full backing of fixed trading community and continues and will continue to be developed just as the other fixed family of standards are developed. And that concludes my remarks.
Thank you, Mike. 有其他的提问吗？许巍，
那个
我想
黄许巍是哪位？您在举手。
对，我看到他，但是他没有。
哦，不好意思，我好像
点
错了，不好意思。
啊，
哦，没问题了吗？So while we'll see whether there are questions. Maybe Mike. Yeah.
Sammy,
So okay. Yeah.
sorry, I think Don has his hand raised.
Don, yeah, please go ahead.
Yeah. Just wanted to mention the question had come up about simplifying messages to make them perhaps more efficient. If you're going to use the tool that is discussed here to generate Google Protocol buffer proto files from Orchestra, we now have a tool. It's actually an Orchestra tool called Playlist that is available to fixed members. And what it does is you could read in the very large Orchestra file that represents the fixed standard, like fixed latest, and then select messages, components, fields, and take an extraction of the very large standard messages and come out with very simplified messages that are more germane to your application. You could then feed the simplified Orchestra messages into the tool that creates the proto file. So I just wanted to mention that.
Okay. There's another. 李叔，我给你打开那个麦克风。
Hi, Barbara.
Okay.
I want to ask a question. What is the current status of fixed GPB? I see from the website that its current status is version 1.0 and draft standard, and which is updated in 2021. So what is the plan of the standard? We all hope that it will become it will become a published standard, not just a draft standard. So it may be a main obstacle to adopt this in our production systems if it is still in the draft standard. So any plans for the future of the protocol? That is my question.
Okay. The plan for the fixed GPP, right? The version 1.0, right? Correct? 对吗?
Yeah.
So okay.
Yeah.
Mike, I think the question is, at the moment, I think when they see is a GPP version 1.0, any future plan? And at the moment, I think it seems to be like a Java standard or something. Is there any future work that going to make it a standard in the future?
Don or Greg, can you comment on the?
Yeah,
Sammy,
sorry. I think
Yeah,
partly Liju, hi, it's been a while. Partly this is a process question. I believe Liju, you may have brought this up once before. This is a process question because with technical standards, we had put in place a process where we hope to be more rigorous, where people would come forth and show that there's interoperability between two independent implementations before it goes into official standard state. This was discussed with Hanno Klein, who's one of the GTC co-chairs, about what do we do when no one comes forth, so to speak. So I think we're hoping to find a way to push this into official standard Li Ju, because this was a question that you had previously raised also. But in terms of future development of the standard, I will leave that to Mike and Greg.
It just needs a chair, right?
Yeah, yes, that too.
Okay, what can we do to make some contributions to the speed up of the standard from the part of Fixed China?
I think if there are implementations in China that are, let's say, between two firms that are using GPB version 1.0 and can show us or tell us that these two firms independently have implemented this and was able to communicate and interoperate between the two of them, then I think that would really help.
See, but you know, in China we have a very limited we only use a very limited subset of fixed lattice. So if we contribute a version which is based on the subset of
Subset is fine. Yep.
Yeah,
that should be fine.
That's everybody.
Everybody just uses a subset. Nobody uses the full fixed lattice.
That would be a whole new achievement to use the whole thing. But no, that would be fine. A subset would be fine. It would just be the interop between the firms. That would be a big deal.
Okay. Thank you.
Great. Greg, anything to add?
No, I agree with Lisa. It's just like a process issue, I think, at this time. I mean, there's some documentation that needs to just be, I think might be tweaking it just to make sure it's conforms to, it supports orchestra, and, it certainly does, but there's just, it's a documentation issue and a process issue. All the decisions that have been made when you convert from an orchestra file into the protobuf file, those have been made, and the tool does that. So that's really no decisions to be made there. It's more of a process issue, as Lisa spoke of.
Okay, thank you. Xiaoping, any question from you? 有什么问题吗？然后其他的问题？
这没有。或者灵魂，你那个问题也可以打个字下来，打字，然后可能更清楚一点，如果有需要的话。
对，是那个Kevin 吗？对，可能。
看看谁还有没有问题。
我还有一个举手是
那个
Kevin，我给你打开你的麦克风吧。
对，那个聊天框里好像打不了字啊。
Q&A 呢可以用吗？
聊天可以打吗？这它显示那个 chat disabled。
其实应该我已经打开了，可能是那个有些时候是那个有一些你再试一下，我再重新 reset 一遍，能打开吗？
哦，能打开，行，我把问题发在群里了。
Okay. So, Mike, the question is it possible to make fixed field keep the same field number across all messages so that we can use small message like only with one field to decode a last message in order to get that field, one field value?
Yeah, I see the chat too. Yeah, keep the same field number across all messages. So does this mean then to have the fixed field message be the same field number in the proto message, so that it was in the same order in the proto message? You could do that if there was no repeating group, but that is not part of the GPB standard to enforce that. But of course, you could keep just the fields that you're using. And so the proto field number, which it has to be in order of how it's declared in the proto file, wouldn't necessarily match the fixed field, but you could still limit the fields in the proto message to just the ones that you're using in fix. That would be fine. If you wanted to map the fixed field number 1-to-1 to the proto field number, you could do it, but you'd have to do it by hand. The orchestra to GPP tool wouldn't do that for you, and you wouldn't be able to support a repeating group that way necessarily, because you'd have multiple repeating fields.
Mike, I was curious, how does protobuf support repeating groups? Because your sample looked very linear to me.
Yeah, it's a message.
I'm ignorant about protobuf.
It's a message within a message. So protobufs, you have to. It's kind of an odd IDL format because you declare the field number. It's not manifest from the order in which you declare them. You actually say this is field 1, this is field 2, which I guess is nice. It lets you reorder them and give them a different number. But the number that you put in there, so like I had in the example, string account equals 1. That's a coincidence. That account is also fixed tag 1. It's just saying this is the first field in the proto message, and so you number them 1, 2, 3, 4, up and up and up, and that's how protobuf knows to decode them in order when it's received in binary format. And so you can have direct access to those fields. It's very efficient to access them directly because you know exactly the offset of where the field is. For repeated fields, it's the same thing. It's just that you're actually embedding. You might say, well, the 10th field in the message is a repeated field, and the repeated field is of type this other message type, or even this. You could even embed the same message type in the message type if you wanted to, but it'd be weird. But that's how you do it. You're actually embedding a message. So it's not really unlike how fix. When you have a repeating group, it's a component, right? Or it's a num group field that's repeated. It's the same kind of concept. There's a whole, you describe that as its own message type, really, and then just declare it as being repeated, but it still has to occur at an offset within the message. So you always have direct access because you always know the offset of every field in the message in the protobuf decoder. So it's very efficient that way.
Number. Okay, now I get it.
Yeah, but it's based on the number that you declare within the proto file. And so you could technically try to map those 1-to-1 onto fixed fields, but you wouldn't really need to. You could just restrict the fixed fields you use to the ones you only care about. But even if you didn't, you wouldn't have the most compact message, but you still have direct access because it's just base plus offset always. You know where the message begins, and you can calculate the offset to where the field occurs. And so it's very efficient to access them.
Yeah, but that's
very different from like a JSON message.
Yeah, but if you're building your own protobuf decoder, right? Programmatically, you don't have access to those sequence numbers, right?
The field numbers in the proto definition?
Yeah.
Well, you would. I mean, you would the same way that protobuf does. I mean, you know that, okay,
yeah,
this is field 1, this is field 2, this is field 3. So yeah, I mean, it's way easier to do that in protobuf than it is in fixed protocol. But something like fixed protocol tag equals value or fixed or any kind of a JSON encoding or something else or XML, you can't do that. But just like any other binary encoding, protobufs are very efficient in that you have a base address at which the message begins, and then you have an offset at which each field occurs, and you can kind of go right to that field by figuring out what the offsets are. Now, when you have repeating groups, yes, you have to take that into account, but then it's just a recursive exercise because the repeated group it's similar to the base of the message. And if you've ever built decoders for those types of custom binary formats like CBOS or whoever else's, or FAST. You know, it's the same exercise. You know where each field occurs. You sort of do a integer math to find where.
Okay. So did you answer the question of, you know, do these tools include this kind of arrangement? So, you know, using the existing tools that you mentioned, can this be arranged? And also, I probably add one more question is, you know, this type of arrangement, does it, you know, conflict with any of the best practices, you know, you're aware of?
Yeah, so I guess, I mean, first of all, there's no need to build anything custom to do any of this. All of the open source standard tools for parsing protocol buffers in any language and also encoding them and sending them in any language, I'll do this for you in a very efficient fashion. Probably the most efficient implementation, or at least the one that I currently know of, is Cat and Proto. Although there's also one called Buff, which I haven't looked at yet, but I think I should, because it aims to be even more efficient maybe at certain of these things. But these tools all exist. They're all open source, and if you wanted to, you know, put some speed hacks into them to make them work even more efficiently, it's all out there. So there's you know, if you can get a very, very efficient encoding, much more efficient than you could get with tag equals value fix, right out of the box, using the off-the-shelf open source tools made by Google. And you're already going to be orders of magnitude more efficient than sending tag equals value fix, with more options for how you can disseminate the messages. Just because out of the box, you're going to get formats that let you serialize the messages over transports that, if you wanted to, you know, broadcast messages, for example, market data, you could, there's ways you could do this that are going to be more efficient out of the box than tag equals value fix over a TCP session. So these things already are there. No special coding or tooling required. It's all open source. And if you wanted to modify them to do things they don't do out of the box, you can do that, because they have liberal open source licenses. The Google stuff is licensed under, it's not literally a BSD 3-clause license, but it's a Google license, but it looks, and I'm not a lawyer, but it looks like all the world to me to just be Google put their own name on essentially a BSD 3-clause license, which is extremely liberal, and lets you use it in a basically unrestricted fashion for your own things. And then the fixed trading community stuff is Apache, you know, APLv2, and that's also quite liberal in what it allows. And then there's associated tooling in the form of quick fix and the related tools, which are also basically BSD, even though it's a quick fix license, but it's BSD compatible, basically, free use with attribution. So similar to protobufs. So yeah, there's really no need to do anything special to get access to the performance benefit of using this encoding versus tag equals value. It's all already there in open source, which also means that if you wanted to put somebody on the task of making it do something even fancier, the code's right there for you, and the license allows it.
Okay. Any further question? 有其他的问题吗？ Seems no further question, but just a quick one in terms of a plug for me. I think just generally, you mentioned about the conversion between orchestra file, you know, and the tools. You know, if people are not using orchestra right now, I mean, can you sort of put it in the other way? What is the benefits, you know, in terms of this sort of application, the benefit of using orchestra? You know, probably just getting more awareness of orchestra in a way.
Sure. I'll let Lisa and Don maybe weigh in on this one, but I will tell you that just the brief version, if you're using the protobuf encoding, is that's a really simple way to get from fixed protocol to protobufs, but also to other things. And it gives you lots of other opportunities for code generation that goes above and beyond anything we've had before. So it includes it includes possibilities for code generation that lets you handle different scenarios, conditionally required fields, and other things in a way that you'd normally have to do by hand, sending documents about rules of engagement back and forth to a counterparty. But I don't know, Lisa, you might have a canned pitch for this, but I'll throw it over to you to maybe
I'll defer to Don. He's got the can pitch.
All right, Don, give it to us. Hit us with the orchestra pitch.
So you've probably heard this before, but our motto for Orchestra is machine readable rules of engagement. And so one of the things that defines is message structures, which is in another format what you get in the proto files, but it also has other features that that you could take advantage of to create rules, and you could express when you have conditionally required fields, like when is it required, and things of that nature. And it also has features for workflow. And one thing I was wondering about that is, and maybe a question for Mike or Greg, do you think that be possible to generate a specification for gRPC coming out of Orchestra? Or would there be a benefit to that?
I think it would be a nice, that would be, so yeah, when you mentioned the workflow idea, which is, so, and when Don, when you say workflow, and you can correct me if I'm wrong, this is things like, this lets us say things like, if you send me a node or single, I'll send you an execution report and it will look like this. And if you send me a cancel, I'll send you this type of response. Is that right?
Right.
Yeah.
Yeah.
It's the orchestration. So yeah.
Right. So that's the kind of thing that we could, that's where we can take a proto file with protobuf, and you can elevate it to something like that client server communication. And we could potentially do that with something like gRPC, where that you could elevate that workflow kind of an idea to a communication like that. And that would maybe be at some kind of an intersection of the GPB encoding standard for fixed protocol, but maybe this may be it might be part of that, or related to it, or a related standard. I'm not sure how we exactly would capture it, but it might involve generating a more specific type of a message. So instead of just an execution report, you might have a specific proto that you would define that would let you create that relationship, so that the client and server would know how to send those back and forth. And that would actually be really nice, because if you have just a pile of proto files in general, nothing specific to the fixed encoding in protobuf, but just if you just hand someone a pile of protos and say, well, here's my protocol, you can talk to me with this, it doesn't tell you anything about workflow, right? Just like if you hand somebody a quick fix data dictionary that says, well, here's the messages I support, it doesn't really, until you have a diagram that says, if you send this, I'll send that, it doesn't really explain all of that orchestration. But this could be, there's a potential there. Yeah, that's a good point. I mean, there's a way we could elevate that orchestration into something that maps on a gRPC, and that would be a very nice thing to have, because that would give you a client and a server that you could generate, not just protos that you could use to talk to somebody. It gives you the orchestration and a way to document what those interactions are. That would be really, really handy.
Thank you.
Yeah, and Mike, I think because Orchestra is pretty agnostic, this could probably be generalized, so it's not specific to fix in terms of the protobuf side too, right?
I think that's true, because it could relate, not because if you could do it in gRPC, you could do it in other things. I don't let's use a bad word. Let's talk about Corba for a second. Like, we could do it. You could do it there, right? Or you could do it. But here's a better example for which I think would be of interest to in the crypto world. A lot of people use web-based protocols. You might have an interest in doing something over a WebSocket. You might have an interest in doing it, doing things over a REST API, and you might want to have a Swagger definition that goes on top of that and lets you know what your client and server requests and responses could be. I could see it building out that way for those types of APIs. And then, you know, then there's others. I mean, there's the Apache family of these things that bolt onto Kafka. You know, I mean, there's quite a number of these types of IDLs that describe clients and servers speaking a protocol that we could generalize it to. gRPC is a really good example, but you're right that, yeah, it could be generalized to other types of RPC mechanisms and IDL languages that describe them. I'm trying to think of the Apache one. Is it Spark? Not Spark. What's the one that's like Protos, but it's Apache? That could be another example of that same thing.
Okay. Any further question? 有没有其他问题？现在时间已经差不多了。小平，我就给你讲几句话。
没什么，反正后面我们就是下一步我们下一次会议会有什么议题啊，我们也会再和我的同事还有一些同行再商量一下，看看有什么可以在下一次会议的时候去讨论和交流的。因为现在这个美国东部时间应该已经很晚了，所以感谢各位专家，我就这些没有什么。谢谢。
Okay. So Xiaoping said thank you very much for everyone dialing in from the States. I think it's very late, so we appreciate your time. We appreciate your your efforts and sharing. I think this has been very helpful. And also the group, I think the China Working Group will discuss to see whether there are other the sort of technical topics that they would love to hear more. And also if there are other materials that I think Greg and might share some material. I think we will sort of format that and share some of this material with the group. Okay. Yeah, with that, thank you very much everyone. 谢谢大家今天的参与。有没有其他最后的这个 comment? Final words from anyone?
Just a huge thank you to you, Sammy, for moderating and translating. Not an easy task when
doing a very bad job.
When you don't live and breathe Google Protocol Buffer. So congratulations on a good job.
All right. Any further comments before we close?
Thank you very much, Sammy, for hosting and translating. I really appreciate it. And thank you everyone for joining. 谢谢你，谢谢。
Thanks, Mike.
Thank you, Mike. Thank you, everyone. Greg. 谢谢大家。
拜拜。
拜拜，谢谢。
Bye.
Bye bye.